Are you a basketball player? Or do you love watching basketball games? Many games you play or learn in your MAPE subjects like baseball, volleyball, and sepak takraw involve flying objects or balls. The curved path that the ball or object follows they make in mid-air is a projectile. That is why for today, our topic is projectile motion, and to be more specific, we'll be dealing with uniformly accelerated motion. Here are the learning objectives. First, explain uniformly accelerated motion in horizontal dimension. And second, solve problems related to UAM in horizontal dimension. A projectile is an object that moves in two dimensions, having both horizontal and vertical dimensions, acted by gravity. Before we start understanding the concept of the projectile, let us focus first on objects moving in one dimension, horizontally and vertically. An object moving at a constant acceleration is said to be in a uniformly accelerated motion or UAM. In other words, the acceleration does not change, it is uniform throughout. So, in this video recorded discussion, we have two parts, the UAM in horizontal and vertical dimensions. For the first part, our attention will be on the topic of UAM in horizontal dimension. In UAM in horizontal dimension, the motion of the object happens parallel to, in the plane of, or operating in a plane parallel to a baseline. To further understand what UAM in the horizontal dimension is and how acceleration becomes constant as an object changes its velocity per time, let us consider an airplane on a runway preparing for takeoff. Now, to analyze the motion of the airplane, we will be using the concepts you have learned during grades 7 and 8, which are displacement, velocity, and acceleration. Now, values here is for your displacement. We denote that as small letter d. Now, the values here are for time. We denote that as small letter t. Now, we have to check the velocity of the airplane as it moves per time. So to do that, we have to use the formula you have learned during grade 7, which is V is equal to d over t. So this is the formula we use for speed and velocity. What makes them different is that your speed doesn't have direction. So here, we are following the direction moving to the right for the airplane, so we use the term velocity. Now, to get the value of v sub 1, that is for the first velocity, so we have to substitute the values here for distance. So for 1 second, it covers 5 meters. So the time is 1 second. 5 over 1 is 5 meter per second. So this is now the value for the first velocity. Now for v sub 2 or the second velocity, we'll be using the values here. And again, we follow the same formula. So v sub 2 is equal to d over t. So we have 20 meters. Since the airplane moves from 1 second here in 5 meters, moving to 2 seconds in this particular distance, which is 20 meters. So we have 20 meters over 2 seconds. So divide this, we have 10 meter per second. So this is now our velocity number 2, 10 meter per second. Now, the airplane moves at 3 seconds here. So we'll be using these values, using the same equation to get the value for V sub 3. So d over t, we have 45 meters over 3 seconds. The answer is 15 meter per second. So you have noticed that the velocity is increasing from 5 meter per seconds to 15 meter per second. So when the velocity changes every second, it means, class, that the airplane is accelerating, bumibilis, right? Now, to check the value of the acceleration, we'll be using the equation you have learned from your grades 7 and 8. So the formula is A is equal to V sub F, final velocity minus initial velocity over time. So we're after with the first acceleration. Okay? So we'll be using the value for your V sub I, which is 0 meter per second. Bakit? Kasi at rest pa lang naman, that is the initial velocity of our airplane. So it doesn't move pa, kaya there's no velocity. So our final velocity is your 5 meter per second minus 0 meter per second over time, which is 1 second. So minus natin to. So 5 meter per second ang sagot over 1 second. Now we don't have units to cancel, no? So it remains here. But to further simplify it, we have 5 meter per second squared. Remember, the unit for acceleration is meter per second squared. Now the unit for velocity is meter per second. Okay? So there are chances that in a sample problem, pwedeng maging kilometer per hour yan, no, for your velocity. But again, you've learned the technique dimensional analysis. You can convert that into its standard unit, which is meter per second for your velocity, and for your acceleration, meter per second squared. Okay? So for our first acceleration, using these values, and our initial velocity is 0 meter per second, we have 5 meter per second squared. Okay? Now for the second acceleration, we'll be using V sub 2 as our final velocity here, and our V sub 1 is still our initial, no, to get our second acceleration. So same equation, V sub F minus V sub I over T. Substitute the values that I mentioned. So we have 10 meter per second minus 0 meter per second over 2 seconds. So deduct this. We have 10 meter per second divided by 2 seconds. So our answer is 5 meter per second squared. That is for our second acceleration. Okay, now for the third acceleration, we'll be using still the equation V sub F minus V sub I, but our values here are for V sub F, this V sub 3, and still our initial velocity is 0. Di naman nagbabago yun. Over T. So 15 meter per second minus 0 meter per second over 3 seconds. So our answer here, deduct this, divide by 3, 15 meter per second divided by 3 seconds, we have 5 meter per second squared. So that is for our third acceleration, 5 meter per second squared. So you have see here, class, or observe that the acceleration remains the same all throughout as your airplane moves, no? So it shows that the airplane accelerates 5 meter per second squared. So therefore, the airplane is moving faster at a constant acceleration. This is now yung sinasabi ni Sir referred to as uniformly accelerated motion. Kahit nagbabago ang distance covered ng object per time, And even if nagbabago din ang velocity, the acceleration of the object remains the same or constant. Kaya, tinatawag natin tong UAM. But in this case, this is for horizontal dimension since the airplane moves parallel to the baseline. Hopefully nasusundan niyo yung definition ng UAM. To derive the formulae needed in uniformly accelerated motion or UAM, we will be using the formula for velocity, constant velocity, and acceleration. So where V is for velocity, V sub F is for your final velocity, your V sub I, that is for your initial velocity, V sub AVE, that means average velocity, and the D here means displacement, T time, and A is for acceleration. So just to review lang class, the unit for velocity is always meter per second. Okay, for displacement, meter yan, that is the standard unit. It could again change into kilometer, okay, basta tumutukoy sa length. But again, you have to convert that into its standard unit through the use of this dimensional analysis. So time, seconds yan. Pwede pa rin naman yung mabago depending on the given problem. Pwede maging hour or minutes yan, but still you have to change it into its standard unit, which is seconds or second. Now, acceleration, meter per second squared yan. So, like what I mentioned or keep on mentioning, pwede din yang magbago, but still you have to change it into its standard unit following the rules for dimensional analysis. So, we'll be tag this formulae as equation A, equation B, and equation C. So, wala naman nagbago dyan. So, we just simply tag it as equation A, equation B, and equation C for us to easily do the manipulation of equation para makaderive tayo ng equations needed for your UAM. Okay? So, your equation A is for your velocity. Okay? Equation B is for your constant velocity. Equation C is for your acceleration. Now, the first step that we have to do is to find out how displacement changes with time when an object is uniformly accelerated. So to do that, let us use equation A and rearrange it. Rearrange equation A. Our equation A is your velocity. V is equal to d over t. So we have to rearrange it for d. Okay, and how can we do that? So we have to simplify this fractional side of this equation by doing the reverse operation. It shows that this is in division, no? So the reverse operation of that is your multiplication. So we have to multiply both sides by t para ma-cancel natin. So cancel, right? So distribute natin yung t here. So dito wala ka nang i-distribute kasi na-cancel na. So that becomes d is equal to vt. Okay? So we're not yet done because we have to again find out how displacement changes with time when an object is uniformly accelerated. So next step is we have to substitute equation B to this equation. So our equation B, para lang ma-recall, is for your constant velocity, which is V sub AVE is equal to V sub F plus V sub I over 2. So we have to substitute this for V. Okay, bilugan ni sir ito. Ito ang isa-substitute natin for V. So making it, excuse me, making it D is equal to V sub F plus V sub I over 2 multiplied to D. Now, saan po galing ito? That came from the equation B kasi sinubstitute natin siya. Kasi V is just the same with this. Okay? So, hopefully following yung sinasabi ni Sir. Now, this is now becomes our equation D. So, we will label it as equation D. And this becomes our equation D. So, moving on, we have to further rearrange equations. Now, for this case naman, we have to rearrange equation C. So, our equation C, recall lang natin, is your acceleration. A is equal to V sub F minus V sub I over T. So, we have to rearrange equation C for V sub F. Okay? We have to rearrange that for V sub F. Now, how can we do that? We have to again, multiply both sides by T para mabago yung fractional side ng equation, which is this part. So, A is equal to V sub F minus V sub I over T. So, multiply natin both sides by T para ma-cancel to. So, distribute this or multiply, that becomes AT is equal to V sub F minus V sub I. So, hopefully nasusundan si Sir. Now, we're not yet done because we're after with V sub F. So, para matanggal tong variable na to on this side of the equation, we have to add V sub I both sides. Okay? Kasi pag inad natin to negative V sub I plus V sub I, cancel. Right? So, what we have right now here from this equation is V sub F is equal to V sub I plus AT. Okay, you have equation na for V sub F. Yun naman ang ating purpose, right? Why we have to manipulate equation C. So, this equation, nung nakuha nating V sub F, we have to use this for equation D. So, our equation D is this. So, we have to substitute this variables for your V sub F. So, magiging ganito yan. D is equal to V sub I plus AT. Okay? So, yan. Dito, plus. Okay? Plus our V sub I over 2 multiply to T. Okay? So, hopefully, nasusundan si Sir with this manipulation of equation. Okay? So, we have this now, pero hindi pa rin tayo tapos. So, we have to combine common terms here, which is your V sub I. Yan naman yung common here. So, combining it, dahil addition ng operation, so this becomes D is equal to 2 VI, dalawang VI yan, kaya inad lang natin 2 VI plus 80 divide by 2 multiply to T. Okay, so next step is we have to distribute T here para ma-simplify pa natin ng further. So distributing this to this, it becomes D is equal to 2VIT, okay, plus 80 multiply to, kaya 80 squared, okay, over 2. So, isi-simplify pa rin natin to by dividing this to 2 and this to 2. So, this is now becomes D is equal to V sub IT plus, so cancel to, dito naman tayo, plus 80 squared over 2. This is now your next equation. We will tag this or label this as equation E. Okay, so this equation E, This shows that the displacement of the body is directly proportional to the square of time. Okay? And this confirms that for equal time interval, okay, so for equal time interval, displacement increases quadratically. Okay? So, ayan ang ating equation, but mapapansin natin later on once we have sample problems na. Okay? So, we have from manipulating equation A, equation B, substituting that to our manipulated equation A, as well as your equation C, nagkaroon tayo ng equation D and equation E. So, we're good na with finding out how displacement changes with time when an object is uniformly accelerated. So, meron na tayong equation E that confirms yung relationship ng displacement and time, no? When the object is uniformly accelerated. The next thing naman na dapat nating ma-derive has something to do with final velocity. So, we have to find out how final velocity or v sub f depends on the displacement. So to do that, we have to use our equation A. Okay, we have to derive it for D. So equation A, to review again, is V is equal to D over T, and we have to manipulate it for D, making it, okay, V is equal to T over T, multiply both sides by T para ma-cancel natin ito. Yung fractional sides, ma-convert into this. D is equal to VT. Okay? Kasi minultiply natin si T with your V. So, in this case, we have to substitute equations B and C. Para kanino? Para for your V and T. Okay? So, you've noticed our equation B is your average or your constant velocity na V sub AVE is equal to V sub F plus V sub I over 2. While your equation C is for your acceleration, A is equal to V sub F minus V sub I over T. So, di na natin i-manipulate pa yung equation V kasi V sub AV is just the same with V. You just substitute these variables to your V. Okay, making it D is equal to V sub F plus V sub I over 2. Ulitin natin saan galing ito. That came from the variables here for your equation B. Okay? So, now for T, okay, we have to manipulate equation C so that we can have an equation for T na masasubstitute natin in this equation, derived equation from your equation A. So, paano po yun, sir? So, we have to still divide both sides by T para mabago natin yung fractional side ng equation. So, by T, cancel this one. So, multiply AT is equal to V sub F minus V sub I. Again, we're after with T. So, multiplication ng operation between A and T variables. So, reverse operation of that is division. Kaya i-divide natin both sides by A. Bakit po A? Para ma-cancel natin si A here, para the variable that remains here is T. Okay, cancel this. Wala naman tayong maka-cancel this, making it T is equal to V sub F minus V sub I over A. Okay, now this is the manipulated equation C for T. So, this variable naman, ilalagay natin for your T. Okay, making it V sub F minus V sub I over A. So, combine natin yung terms kasi multiply natin to para ma-simplify. Okay? So, magiging D is equal to Multiply to v sub f, multiply to v sub f, v sub f squared. Right? Then, positive v sub I multiply to negative v sub I, magiging negative v sub I squared over 2a. Kasi minultiply lang natin. Now, rearrange this for v sub f kasi we have to find out nga how final velocity depends on displacement. So, we have to rearrange this for v sub f. Paano po yun, sir? So, still, dahil fractional side ito, we have to multiply both sides by, by 2a. Okay? So, hopefully, nasusundan si sir sa sinasabi. So, making it d is equal to v sub f squared minus v sub I squared, okay, over 2a. Multiply natin in both sides by 2a to cancel this one. So, multiply natin to, that becomes 2ad is equal to v sub f squared minus v sub I squared. Okay? So, moving on, dahil kay v sub f tayo after, may katabi siyang negative v sub I. To remove this from this side, we have to add it to negative v sub I squared. Same variable, right? So, cancel this one. Okay? Not negative here. So, wag to pansinin. So, v sub I. Okay? Kasi negative to plus v sub I. Okay? That will be 0. So, magiging v sub f squared is equal to v sub I squared plus 2ad. So, this is now our equation letter F. Okay, kasi natigil tayo kay equation E. So, we're good now with deriving all the needed equations for uniformly accelerated motion. So, the next thing naman na gagawin natin is to apply these derived equations to the following sample problems. Again, horizontal dimension pa rin tayo. Okay? Now, to sum up everything, yung mga na-derive nating equations, so we have here equation B, equation E, and equation F. So we'll be using this to answer the given sample problems. Okay? Now, for sample problem number 1, an airplane accelerates from rest on a runway at 5.50 meter per second squared for 20.25 seconds until it finally takes off the ground. What is the distance covered before takeoff? So, napansin nyo, I already provided these equations. So, para later on, we can identify easily which equation we're going to use to solve this problem. So, moving forward, tuturo ni Sir yung technique para hindi kayo mahirapan to find out what equation is needed to solve this problem. Okay, and we'll be using here Gressa method para mas maayos ang ating pag-solve. Okay, now according to Albert Einstein, imagination is greater than knowledge. Kaya para mas maintindihan natin tong problem, we have to illustrate it. Okay? So, it says here that airplane accelerates from rest. So, let's say the dot signifies the airplane. Okay? So, runway, and the acceleration is 5.50 meter per second squared. So, bakit nasabi ni Sir that this value is for acceleration? Kasi I look to the unit. I mentioned earlier, meter per second squared is for acceleration. So, it moves from rest. So, the word rest means the initial velocity is 0 meter per second. So, at 20 seconds, no, the time for it the airplane finally takes off the ground. So, 20.25. Yun na, nakaangat na si airplane. So, from this point to this, we have to identify the distance covered. Ayan yung ating way to analyze it through illustrating it. Okay? So, grasa method tayo, G for the given. So, write lang natin mga given natin. We have initial velocity. Kahit wala siya sa problem class, we have to analyze it. Sometimes words provide values, no? As added given. Okay? Rest means nothing happens. So, therefore, initial velocity is 0. V sub I is equal to 0 meter per second. Velocity pa rin yan. The acceleration is still our given, 50.50 meter per second squared. The time here is 20.25 seconds. So our required value to be solved is for D. Sabi kasi, what is the distance covered before takeoff? So bago umangat ng airplane, how far, okay, yung length covered by the airplane for it to finally takes off the ground. Okay? So here, the technique that I'll be using, I'll be teaching to everyone para malaman kung anong equation ang gagamitin natin to solve this problem. Okay, look tayo sa given. Okay? So use the given as well as the required variable to be solved para alam natin kung anong equation. Equation D ba? Equation E or equation F? Kung equation D ang gagamitin natin, let's see if all of these variables are present for our given and required. May B sub F tayo sa given? Wala. May B sub I? Yes. May acceleration ba dito? Wala. Pero may time. Pero hindi natin to gagamitin kasi some variables for your given are not present here. So we cannot substitute. Equation E, check natin. So di ang hinahanap natin, may B sub I, check. May time, check. May acceleration, check. Okay? So equation E ang gagamitin natin. Now, sir, why not F? So wala pa rin tayong B sub F sa ating given. Right? Though may B sub I tayo. Okay? At D ang hinahanap naman natin. So we cannot still use this. So hopefully nasundan nyo si sir on how I analyze the given and the required variable to be solved para ma-assess natin kung anong equation ang gagawin. Okay? So therefore, equation E, that is D, is equal to V sub IT plus AT squared over 2. So substitute lang natin yung given natin. Okay, for our solution. So this becomes D, wala yan, that is the unknown variable, is equal to V sub I, 0 meter per second, multiply kay T, which is 20.25 seconds, plus acceleration natin is 5.50 meter per second squared, multiply to your time, but we have to square it. Okay. Over 2. So, kung i-analyze natin to, 20 multiply to 0 multiply to 20.25 is 0. So, cancel na natin. Dito lang tayo mag-work. So, 5.50 rather, meter per second squared, multiply to the square of 20.25 seconds. Ang magiging sagot natin dyan using your calculator is 410.0625. Okay? So, copy all the numbers no, na nako-compute niya sa calculator. Hindi pa tayo mag-round off or maglalagay ng answer into 2 decimal places. Okay? So, sa final answer natin yung gagawin class. So, the unit now becomes second squared kasi unit still is being squared. Okay? So, sana nasusundan. Divide by 2. So, multiply natin to and divide by 2. We have, okay, 2,000. Muna, 2,255.34375. Okay, cancel similar units kasi they are positioned no on opposite sides. This is sa denominator side, no? So ito hindi naman kaya
na-cancel natin. Now, what remains here is meter. Divide by 2. Our answer now, D is equal to, when you divide this, you have 1,127. So, dito na tayo to 2 decimal places. So, 0.67. So, yung katabi ni 7 ay hindi naman more than or greater than 5. So, it will never affect the 7. No? Hindi natin siya i-round off. Okay? So, the unit for distance is meter. Kaya tama tayo sa ginagawa natin kasi when we cancel units here, meter is the unit na natira. Okay? So, our answer now is 1,127.67 meters. That is the distance covered ng airplane before it takes off the ground. Okay? So, hopefully, nasusundan si Sir. Okay? So, let's have the next sample problem. So, I already provided still the equations para ma-apply natin yung technique na tinuturo ni Sir. So, from rest, a jeepney accelerates uniformly over a time of 3.25 seconds and covers a distance of 15 meters. Determine the acceleration of the jeepney. Now, in this case, kung i-illustrate natin yung problem, so yung dot again signifies the jeepney from rest. Sabi ng problem, so ang initial agad na velocity 0 meter per second, right? From rest, it accelerates uniformly over a time of 3.25 seconds. That covers 15 meters. Yan yung na-cover ng pag-move ng ating jeep. So, we have to determine the acceleration. Ayan yon, no? So, our given are the following. V sub I, 0 meter per second. Kasi that came from the word rest. Okay? Our time is 3.25 seconds. And the distance is 15 meters. We are asked to compute for the acceleration, okay, of the jeepney. Now, to identify which equation yung gagamitin natin, again, look tayo sa ating given as well as sa required variable. Gagamitin ba natin sa equation D? Check natin. So, may D naman tayo na variable, may time, walang V sub F, pero may V sub I. So, we cannot use this one. So, equation E gagamitin natin. So, may D tayong value, may V sub I tayo, may T tayo, may T, at hinahanap natin si A. Check, no? Pasok. Yung F, bakit hindi? Wala tayong V sub F. Though hinahanap natin si A, may D naman tayo, right? So, V sub I meron. So, we cannot use this kasi wala naman tayong value for V sub F. Okay? Sana nasusundan. Ganyan din how you will solve problems na ibibigay ni Sir for your activity. So, assess the given and the required. Compare it to your equations D, E, F para malaman nyo kung anong dapat gamitin na equations. So, we'll be using still equation E, which is D is equal to V sub I T plus AT squared over 2. Substitute natin yung given para we can further solve this. So, may D tayo, 15 meters. V sub I natin, 0 meter per second. Multiply natin yung kay time na 3.25 seconds. Plus, sa ating acceleration na wala, remain natin as is. And yung time natin na 3.25 seconds, i-square natin yung divide by 2. So, automatically, wala na to. 0 multiply to 3.25 is 0. So, we have 15 meters is equal to A. Square na natin to. That gives you 10.5625. Right? Sabi ni Sir, wag muna tayo magra-round up para sa 2 decimal places. Final answer natin ginagawa yun. Second squared. In-square na din natin yung unit. Okay? So, divide by 2. So, divide natin to. Okay? That gives you 15 meters is equal to So when we divide it to 2, yung 10.5625, that gives you A is equal to A. Our answer here is 5.28125. Okay. Second squared. Okay. So this answer came from this operation na ginawa natin. Dinivide natin sa 10.5625 kay 2, kaya ito yung sagot. Now, dahil after tayo kay A, para mawala itong value na to sa side ni A, divide natin both sides with this. 5.28125 second squared, 5.28125 second squared. Cancel this one, right? What remains here is the variable A. Now, for our answer, A becomes, divide lang natin to, 15 divide by 5.28125 second squared. So, titingnan natin, wala naman tayong makakancel na unit. So, that means meter per second squared. That is really the unit for acceleration. So, our answer here now is, okay, 2 decimal places tayo. So, walang mara-round out, kaya 2.84 meter per second squared. So, this is now our answer for the acceleration of the jeepney having this distance covered as well as the time. Okay? Which is 3.25 seconds. Okay? Hopefully, nasusundan si Sir ng maayos. Okay? So, moving on to the last example or last sample problem. Nandyan pa rin, binigay pa rin ni Sir ang equations para madali nating ma-assess. So, a train accelerates to a speed of 20 meter per second over a distance of 150 meters. Determine the acceleration, assume uniform of the train. So, let us assume that this is in uniform accelerated motion. So, illustrate natin yung problem. Yung dot signifies the train. So, it accelerates, bumilis, to a speed of 20 meter per second. So, this is your final velocity kasi this is your initial. 0 meter per second. So, from initial, moving to this final, nag-accelerate naman talaga siya. 0 to 20 meter per second. So, there's acceleration happening here. So, it covers 150 meters. Okay, at 150 meters, the final velocity is 20 meter per second. So, ang hinahanap natin is the value of the acceleration. Given, V sub F natin, 20 meter per second. A-analyze dapat ng maigi yung problem para hindi nawawala. Okay, para tama ang mga na-identify na values. V sub I, 0 meter per second. Our distance is 150 meters. We are required to compute for the acceleration. Our equation, tingnan natin kung magagamit natin si D, having this given and variable to be solved. Wala tayong A dito, so automatically hindi agad. Okay, kahit may V sub F ka, may V sub I, may D, wala ka namang A. Okay, equation E, wala din, may A tayo, pero wala tayong V sub F. Hindi din natin magagamit to. So, V sub F, equation F na lang ang pwedeng gamitin kasi may V sub F, may V sub I, may A na hinahanap, at may D. Okay? So, hopefully nasusundan si Sir. So, check tayo sa equation F. So, copy natin yung equation F. V sub F squared is equal to V sub I squared plus 2AD. Substitute natin yung mga given natin for our solution. So, V sub F, 20 meter per second. I-square natin yan. Is equal to V sub I natin 0 meter per second. I-square din natin yan. Plus 2. Remain natin si A, yan yung ating unknown variable. Yung D natin is 150 meters. Since 0 to, kahit square mo yan, 0 pa rin yan, di na natin yan ilalagay pa. So, 20 meter per second squared, i-square pa natin. So, that becomes 400 meter square. Pati unit na i-square. Second squared is equal to, okay, 2A multiply to 150 meters. So, multiply na natin to. Okay? Yung 2A to your 150 meters, magiging 400 meters squared, second squared is equal to, magiging A 300 meters. Right? Kasi ito, minultiply lang natin si 2 to 150. Okay? So, dahil A ang katabi nito at yun ang hinahanap natin, multiplication to reverse operation, divide both sides by 300 meters. To cancel it, para ang ma-remain natin na A na variable. Kasi yun ang after natin. So, when you divide it, cancel similar units, may natira pang M na isa kasi 2 minus 1, no, imagine that there's 1, 2 is 1, so may isa ka pang M. So that gives you answer na when you use your calculator. So 2 decimal places lang tayo. So 1.33. Okay, what is the unit? Meter. Yun. Per second squared. And that is the unit for acceleration. So this is now our answer for sample problem 3. So hopefully you learn something for this discussion na UAM in horizontal dimension. Make sure na magagamit yung technique that I shared here in this video recorded discussion. Okay? So moving forward, madali na lang din yung matututunan UAM in vertical dimension. That is for part 2 of this